Hi everybody, this is Mrs. Haynes. Welcome to the quarter 2 review. For Algebra 2, we're going to be covering chapters 5 and chapter 6, the sections that we covered, of course. And there'll also be some information that'll help you with chapters 3 and 4, so I'll address that. In addition to having your homework, you may want to also have some extra paper in case I do it in a more straightforward way, or you want to take extra notes. Also have your note card because you might have some ideas of things to add. One of the things that makes finals more tricky than chapter test is you're synthesizing information from all over. And so thinking about what kind of a problem it is and how to approach it is the first step. Because after you know how to approach it, then it's just a question of execution. So anything you can put in your note card to help you know how to approach certain kind of problems will probably be useful. So let's jump into the white screen, or whiteboard, sorry. Okay, let's get started. So the first problem, write the polynomial 3x, x minus 4 times x minus 4 times x plus 1 in standard form, then classify it by degree and number of terms, okay? So there's a lot of vocabulary in here, so I'm going to take a little extra time and talk through it. First of all, a polynomial function is no fractions, no radical signs, and only positive integer exponents on a single variable. So what does that even mean? If you want to do an example, so a polynomial, I'm just going to do p just to remind you that's a polynomial function. We could have done f of x. It's always going to be constants, and oops, make that a b. Okay, and these numbers, how many terms are in it depends on how high this goes. If that was 15, you'd end up with 16 terms. So it could go as high as just however high it goes, okay? So that's a polynomial function. And then another thing to know about it, the degree of a polynomial, you may want to put this in your notes, is the highest exponents on variables in a single term. Which begs the question, what's a term? So a term is anything separated by a plus or minus sign. So this one has 1, 2, 3, 4, 5 terms because there's 5 different things. So it's a coefficient and any combination of variables raised to an exponent. So this particular one would be, if we were going to classify this one, the degree would be 4 and the number of terms would be 5. Okay, now you're supposed to know some words. If it's one term, that's called a monomial. Doing some Greek here. 2 terms, binomial. We talk about binomials a lot. 3 terms, trinomial. But it also can be called a cubic polynomial. And 4 terms is a quartet, but I think after 4 you can just use numbers. Okay, so now that we've done that level of review, if you need to pause it and write that down, you can. We're ready to jump in. So we have this, so we know our polynomial is this. The problem is, oops, forgot the 1. The problem is it's not in standard form because standard form says no parentheses. So if you had the numbers 4 times 5 times 3, you can't multiply everything at once. You multiply 2 of them, you take your answer from that, and you multiply the third one. Same thing here. So we're going to multiply these 2 together, and we're just going to distribute the 3x to each term in the parentheses. So we have 3x squared minus 12x. And just like, so that's kind of like the answer to 4 times 5. So we take our answer for that and we multiply it by the next factor, because we had 1, 2, 3 factors. Just like this is 1, 2, 3 factors. We're combining together to make a single one. And since we have two binomials, FOIL works. Okay, 3x squared times x is 3x cubed. I do the outside ones. 3x squared times 1 is 3x squared. Then I do the inside ones. Negative 12x times x is negative 12x squared. And then I do negative 12, and then I do last, which is the last one in each of the binomials. And that's going to be minus 12x. Okay. Combining like terms. 3x cubed minus 9x squared minus 12x. Okay. And it's a cubic trinomial. So notice the highest power is cubed. So it's a cubic trinomial. And if you just called it a trinomial, that would be okay. And it has a degree of 3. Because it's got 3. It's a trinomial because it's 3 terms. Cubic is because it's to the 3rd power. Okay. One down, however many more to go. Next one's a little trickier. Find the zeros of, and I want you to do this by hand, not on the calculator. Okay, so first of all, you want to pull out, when you find the zeros, you may want to make a note. What does find the zeros mean? What you might even want to do for your note card, instead of just writing formulas and stuff, is just say, what do I do when it says find the zeros? And the answer is change function to equation equal to 0, solve for, factor out GCF, if left with the quadratic, solve by factoring, then setting each factor to 0. The only reason I'm writing this off is a lot of people are missing these every single time. We learned it in chapter 3 and it keeps coming up and it's still kind of hurting people. Set each factor equal to 0. Or if left with the quadratic, you can solve by this method, or you can solve by the quadratic formula. Usually the factoring method is easier if it's clean numbers, but if you can't get it to work, you can always go to the quadratic formula. So we're going to change the function to 0, and we're going to factor out the greatest common factor. Okay, so it's kind of like if you had, I'm trying to think of a good number, if you had 20 and you factored it into 4 times 5, that's kind of what we did here. This is kind of like, let me spotlight this. This is kind of like the 20, and we factored it into 4 times 5. Now this one won't factor anymore, so we're done, but this one will factor again. And so this is going to be like the 4. And so it's kind of like we've got to split this one into 2. So we're going to recopy this one because it won't factor anymore. And this is a trinomial, and that almost always factors into 2 binomials. So I'm going to go ahead and work it on the side so it's not messing anything else up. But I need a little more room. So I am going to factor this. So I'm going to do it with the diamond method. So remember, this is AC and this is B. So our B is 2, A is 1, C is negative 20. So we've got to think of 2 numbers that multiply together. Oops, just realized that's a 1. It's embarrassing. When I pulled out the 2, I'm going to double check this. 2x times x squared is 2x cubed, check. 2x times 1x is 2x squared, check. 2x times negative 20 is negative 40x, check. Okay. I'm going to do some erasing. Okay, so we had negative 20 up here, positive 1 down here. So I've got to think of two numbers that multiply together to make negative 20 and add together to make 1. So I know one's going to be negative, one's going to be positive. The bigger one's going to be positive because my b is positive. So I'm going to choose 5 and negative 4. So it's going to be x plus 5 and x minus 4. I want you to keep writing this equals 0 all the way down. Now this is the step that messes a lot of people up, and I want you to show this step. So look at your homework, and if you didn't show it, add it, because I'm going to want to see it on the test. So the trick now is if we're solving for zeros, we've got to set each factor equal to 0. So I'm going to change colors here. This is a factor, this is a factor, and this is a factor, because a factor is a number that's multiplied together to make a bigger number. So let's go back to black. So 2x equals 0, divide both sides by 2, x equals 0, x plus 5 equals 0, x equal negative 5, x minus 4 equals 0, x equal 4. Now you can't leave your answer like that because we had to do this to find the zeros, but this is what the answer would have been if it had started out as an equation and they had asked us to solve it. But they asked us to find the zeros. So x equals 0, x equal negative 5, and x equal 4 are actually vertical lines in a function. So the answer is the zeros are 0, negative 5, and 4. And obviously you can do those in any order. Okay? That's number 2. Number 3, find the real solutions of x to the 4th minus 2x cubed equal 3. Okay? So first of all, and it says using a graphing utility. That's just fancy word for using a graphing calculator. Round each solution to the nearest hundredth. So first of all, we have to put it into a polynomial equation in standard form. And that means we need everything on one side and 0 on the other. Okay? And since they want us to do using a graphing utility, we're going to take the equation and change it to a function. So the equation to a function. Okay? And you're going to put that in your calculator. I'm pretty sure everybody knows how to do that. If not, go back and watch one of the old graphing calculator videos. Okay, first of all, before we enter it in, I want to talk about a couple things. One is the most number of turning points is going to be 3, and they want us to find solutions to this. So remember, since the goal is to find solutions to this, the solutions to an equation are the same as the zeros of a function. If you want to write that down, the solutions to an equation in standard form, that means equals 0. So standard form, if you want to put in parentheses, means equals 0, are the zeros of the function. It's backwards of what we did before. Okay? So when you graph that, it's going to look something like this. Okay? So I'm assuming windows are important. We talked a lot about windows. Hopefully everybody knows how to set those. If you're in standard, then you've got the x and the y at negative 10, positive 10, and it probably looks something like this one on the left. Okay, just to be sure that we didn't miss something, it looks like these are shooting up into positive infinity on both sides, so you're probably okay. But you may want to make it your x is negative 20 and positive 20, just to make sure that you didn't miss a 0. To make sure that it didn't, let me change colors here, to make sure that it didn't swing back around and trick another 0 that's off your screen. Like if your screen is like this, you might not see that it's going to curve around and hit a 0 somewhere. There's a chance that could happen. So when you do that and you see you're good. Now the other thing that can happen You're zoomed out enough to see the only two zeros, and that's good. I'm going to take off this red stuff. But you may not be close enough to really be able to hone in on the two parts. So if you look at it and you count the little tick marks, you can see you might want to make your X windows -5 and +5. That way it's going to be easier to calculate the zeros. Okay? So let's suppose you have your X at -5 and +5, and you're calculating the zeros. And if you don't know how to do that, you should go back and watch a video, but I'll just talk you through it really quickly. What you're going to want to do is you go to calculate. It's at the top. It's a blue function. And then the choice, you're going to want zeros. And then you'll notice a little X thing, like a little X cursor. And if you can't see the X cursor, look at the bottom. It's going to say X equal Y equal. And it's going to tell you what that X value is. And that'll tell you if you're off the screen and you need to scoot bigger or smaller. So the XY that you see at the bottom of your screen is always going to be the location of wherever your mouse is, wherever your cursor is. I guess that's a better way to say it. So you're going to have to do the zeros in two places. And after you hit it, it's going to say left bound ? That means you need to be on the left side of the zero. And it should be obvious that the left side of that zero, the Y is going to be positive. So you can tell you're a little bit over if you've got a Y positive on your cursor reading. And when you're happy with that, hit enter. As soon as you hit enter, it's going to set a little dotted line saying, hey, that's your left bound. And then it's going to say, hey, you need to get on the right side of that zero, right bound. So you need to set a line on the right side. And obviously for this particular one, you're going to want your Y to be negative. And then you're going to hit enter. And after you hit enter, it's going to say guess. To get the most accurate guess, you're going to want to move your cursor so it's right on the dot or pretty darn close. And when you do that, you're going to get -1. And since we're solving for it, you don't care. Well, the Y is going to be 0 because that's what we're shooting for. So X equal -1 is going to be your solution from that. And then you'll repeat that same process over here. And it said to round it to the nearest hundredth. And you get X equal 2.26. If you make your cursors tight enough, you should get that within the nearest hundredth pretty easily. Okay? Okay, problem 4. This one's a bit harder. 2x cubed minus 7x squared plus 9 equals 0. And they want you to find all of the rational roots. Okay, here's some good news. If they say rational roots, what rational means is it's going to be a number that's either going to be a terminating decimal or a fraction with integers or just integers. So in that particular case, because it said rational solutions, you can actually do it with the graphing calculator. So you can change your equation to a function. And you'll notice because that's a cube, that means the highest number there could possibly be is 3 zeros of the function. It might be less, but there could be at least 3. So what you're going to do is you're going to graph this. If you don't see 3, make your X windows bigger. When you do see 3, you may want to make them small enough so that you can zoom in on each one. And then you're going to do, I'm not going to repeat it because we just did all that for the calculating zeros, for the right bound, left bound, and all that. And when you do that, you're going to get well, you're going to get the zeros, but since the original problem was solve, and I know I make you guys say this, so I want you to write down what solve means. Solve means find all the values of X that make the equation true. And we want all the values of X that make Y equal 0. So when you run that, you're going to get, when you run the first one, you're going to get -1. When you run the second one, you're going to get 1.5. And when you run the third one, notice how close these are to each other. If you're zoomed out, like if you're on X equal -20, X equal +20, you may not even be able to tell that the function is turning around, because especially these two are really close together. So as soon as you see that all the stuff is happening right around here, go ahead and make your window smaller. That way you can zoom in and get a really good look at what's happening. It's like taking a magnifying glass and looking at something that's teeny tiny. I've seen some of your note cards, and you're going to need a magnifying glass to see those. So anyway, that's how you do those. That's problem 4. I promise these are going to pick up speed a little bit. Okay. Wow, I just realized I didn't. Okay, 5 is pretty tricky. We have to find all the complex roots of x cubed plus 2x squared plus x plus 2 equals 0. Because it says complex, you know it's going to include imaginary numbers, so the graphing calculator is going to be fairly useless. So that doesn't help. So it means graphing won't help. So if you want to put that on your note card, you can. Notice there's 4 terms. 1, 2, 3, 4. When that happens, almost always a good thing to do is going to be the grouping method. And remember how the grouping method, we haven't done that in a while. So I'm going to do a little line here to remind us. So the first 2 terms will be in group 1. The second 2 terms will be in group 2. And we factor each group. So we end up with x squared times x plus 2. I messed that up earlier, so I'm going to double check. Let me put the spotlight on it. X squared times x is x cubed, that checks. X squared times 2 is 2x squared, that checks. Okay. This one doesn't factor, but what's going to make it work better is if I put a plus 1, x plus 2. So even though nothing factors, I need it for the grouping method. So 1 times x is x, 1 times 2 is 2, so it works. Notice how these are an exact match. That means we have x squared plus 1 is one of the factors, and x plus 2 is the other factor. So that's basically a fancy distributive property. So we have this and this. We're both being multiplied by the same thing, so we can rewrite it. This step we don't do very often, so make sure you really understood how we made the jump from there to there. Now we can do what we always do and set each factor equal to 0. So we have x plus 2 equals 0 and x squared plus 1 equals 0. Because this one's more complex, that's why I didn't want you to skip this step and just go straight to saying what they were in the earlier problem. So subtract 2 from both sides, x equal negative 2. This one, we've got x squared equal negative 1. We square root both sides. And don't forget, this is a plus or minus. So we have x equal plus the square root of negative 1, and we have x equal negative the square root of negative 1. And the square root of negative 1 is I, so this is going to be I. This is going to be negative I. So the 3 solutions are, just realized I forgot to take it out of x. X equal 3, x equal negative 2, x equal I, and x equal negative I. That was a hard one. Let me double check something. Okay. Let's move on to number 6. Hang on, I got to pause it for a sec.